Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about hydrocarbons. So, you know what is the meaning of hydrocarbon? The compound which contains carbon and hydrogens. So, hydrocarbon can be open chain or cyclic. Maybe double bond, maybe triple bond present. So there are classification of hydrocarbon. Hydrocarbon, either it is open chain, we called it aliphatic. Another is the cyclic. Now open chain further classified into two parts. First one is saturated alkane and the second unsaturated alkene or alkyne. You know, my friends, what is the meaning of alkene and what is the meaning of alkyne. And then saturated compound further classified in straight chain and branched chain. And then unsaturated further straight chain and branch. Now cyclic system further classified in saturated alicyclic and unsaturated. And unsaturated further classified into two, aromatic and non-aromatic. So this is the pictorial diagram of classification of hydrocarbons. Now friends, you know the alkanes. Alkanes are aliphatic saturated hydrocarbons containing carbon, carbon and carbon hydrogen single covalent bond. General formula CnH2n plus 2. So why hydrocarbons is so important and why it is a starting in organic chemistry? Because you know derivatives of hydrocarbon are all functional groups. So you know about the isomerism in alkane. Alkane is showing isomerism. How? Look at this. You have here 4 carbon in this compound. Also 4 carbon. But the arrangement is like that. Automatically name will be different. So this is the normal butane and this is the isobutane. And these two compounds with the similar formula, and here is also this compound C5H10, but there is name is different. So here you can see 5 carbon, you can write in 3 ways. If you like write like this, then this is called pentane. If you write like this, then one branch you have introduced 2-methyl butane, and if you write like this, 2,2-dimethyl propane, neopentane. So these 3 structures are isomers to each other. Now conformations in alkane. Know the conformations. Look at here. Conformations about carbon-carbon single bonds. This is a stereoisomerism also, or conformational isomers. So it is represented by many ways. I am going to show you this. This compound, simply ethane. If you look at the arrangement, so this carbon and this carbon, if this hydrogen is this hydrogen and this hydrogen, if you arrange like this, this is the static form and this is the eclipse form. For this, I will show you the models in next video. So this formula and writing style is known as sawhorse. Another writing style with this point and this big star is carbon. And one carbon is like that, contains three hydrogen, another carbon. If the arrangement is like that, then it is staggered. If arrangement is like that, then it is called eclipse. And this writing style and graphical presentation is known as Newman projections formula. Now friends, the preparations is also important, but here you can remember many things: reactant, product, and the reagent, and conditions of the reactions. Like this, alkene, you can make ethane in the presence of platinum or palladium, condition room temperature, or nickel, high temperature and high pressure. If you have double bonds in presence of palladium platinum, you will get the alkane. From alkyne, if you have palladium platinum room temperature, you will get ethane. So general formula, you are introducing hydrogen in alkene and alkyne, you will get the alkane, and the general formula CnH2n plus 2. This is the method of preparation, one method of preparation. There are many methods of preparation. From alkyl halides, you can make the methane, ethane, like that. By using reactive metals, if you have alkyl halide and you have reactive metal like sodium, so two molecules methyl bromide will give the ethane. And alkyl magnesium halide, you know, this reagent is very renowned reagent, Grignard reagent. How you will prepare Grignard reagent are XMG. In dry ether conditions, you will get the RMGX, alkyl magnesium halide. This is your Grignard. From this reagent, you can synthesize many compounds. If this compound react with water, you will get the alkane. If this compound react with water, you will get the methane. Examples. So you have many hydrocarbons in alkenes. You can see from 1 carbon to 6 carbon atom, different nomenclature. Their molecular mass different, difference in boiling point, difference in melting point. Here you can observe for your competitive examination how it is increasing, like this. Now chemical properties of alkene. So halogenation of alkenes. Halogenation means how you will add halogens. So this hydrogen is transferred with the chlorine. This chlorine and another hydrogens. So this hydrogen further replaced by this chlorine in the presence of UV light. And finally, 4 hydrogen replaced by chlorine. So tetrachloromethane. You can synthesize this compound starting from methyl. So this is the order. If you have the fluorine, more Cl2Br2I2 and 3 degree, 2 degree. If you have the propane, then you have the two products. One product predominant over another product. So this is the chloropropane and this is 2 chloropropane. 50%, 55%, 55%. You can see with the help of ethane, bromination, bromo, ethane. Here if you have the 3, again you have the two products, 97% and 3%. Here you can see 98% and only 2%. Here you can see 99% only trace. So you have to observe why it is happening. So chlorination reaction actually is the periodical. So you know the periodical mechanism in 3 steps: initiation, terminations and propagations. So first initiate, last terminate and in between propagation. We have the combustions if you have alkane under oxygen, you will get the carbon dioxide in H2, an amount of energy. Pyrolysis means breaking of this compound. You are getting the fractions and cracking many of hydrocarbon. Reforming. If you have this N-hexane in presence of vanadium pentoxide, you will get the benzene, and this is the reaction conditions. So uses of alkanes, a lot of uses. First, 4 alkane are used as a fuel, mainly for heating, cooking purpose, and for example LPG and CNG. Petrol, diesels are used as fuel for the automobiles. Lower liquid alkanes are used as solvent. Alkane with the more than 35 carbon atoms, tar, are used for road surfacing. Waxes are high molecular weight alkanes. They are used to lubricants. They are also used for preparation of candles, and carbon black that is used in manufacture of painting, ink, shoes polish. So my friends, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.